Welcome to this lesson on parallel and perpendicular lines in the coordinate plane. As in previous lessons, these first few slides are ones that you'll either want to do a screenshot of or take down a few notes from. So you can pause the slides as necessary. This is slide 1, slide 2, slide 3, and slide 4. Okay, so using this information, what we're going to try to do first is find the slope of each line. So we'll use this picture for several different slope calculations. The first one is the slope of line AB. So in using line AB, we're talking about right through here, this line, and I have 2 points, point A and point B, that I'm going to use. And we can see that A, if I go left 2 and up 7, that it is at -2, I can write with this, -2, 7, and that B is over at +3, 7. Okay, so we're going to find the slope between those two coordinates. So -2, 7, and 3, 7. I let -2, 7 represent the x sub 1, y sub 1, and 3, 7 represent the x sub 2, y sub 2. I then apply the formula. So I'm going to subtract the 7s. So you notice that here the 7s are the same in the y value. Whenever you have the same y value, you have a horizontal line, as you can see by looking at line AB. When you have a horizontal line, you're going to have a slope of 0, just as we saw earlier. 0 slope is a horizontal line. So since we had the same y values, it was obvious that we were going to have a slope of 0, which is what we get when we plug into the slope formula. 7 minus 7 being 0, 3 minus -2, same as 3 plus 2, or 5 on the bottom. Doesn't matter, it's still 0. So we have a slope of 0 because we have a horizontal line. Now let's look at another line in this picture. So line AC. So again, we know we're at -2, 7 for point A, but in finding point C down here, we are at +4, +2. So I'm going to use -2, 7 and +4, +2 as my two coordinates to find the slope. Again, I'm going to apply x sub 1, y sub 1 to one of them, and x sub 2, y sub 2 to the other. It doesn't matter which one you apply them to, so don't feel like you're stuck, like having to look left to right, calling the one on the left x sub 1, y 1, and the one on the right x sub 2, y sub 2. It doesn't matter. Whichever one you do that to, it'll still work out. You may end up having two negatives that just result in a positive, or in this case, having one being positive maybe on top versus being positive on, negative on top versus being negative on the bottom. So it really doesn't matter in the end. Your answer will work out the same either way. Alright, so applying the slope formula, again, y sub 2 minus y sub 1 over x sub 2 minus x sub 1. In this case, we did 2 minus 7, and did that over 4 minus -2. We got -5, 6. And I'll just show you real quick, if we had done it the other way around, that it really didn't matter. So if instead of the -2, 7 being x sub 1, y sub 1, if I had made it x sub 2, y sub 2, this would have just been written as 7 minus 2 over -2 minus the 4. Well, what that's going to give me on top is a +5, where when I did it before I got a -5, and on bottom it's going to give me a -6. Well, positive number on top, negative number on bottom is still a negative number, so it's still -5, 6. So again, it really doesn't matter which one you call x1, y1, and which one you call x2, y2. What really matters is once I start with a y value, like if I start with this y value and subtract the other one, then I've got to also start with this x value and subtract the other one. I have to start with the same x value that matched up with the y value I began with. Okay. Either way, I'll get the same slope, negative 5/6. In finding CD, you should see that as you move left to right, it's going upward, so we should get a positive number. It's a positive slope. And we see that D is found at negative 2, 1, and that C is found at positive 4, 2. So we'll use those values, and we'll plug into the slope formula. And we'll get, for using this one, 1 minus 2, the blue numbers being subtracted, over negative 2 minus 4, the green numbers being subtracted. These are the blue numbers, the y values, the green numbers, the x values. Okay. Common mistake that I see sometimes is people trying to subtract an x and y value in the same coordinate. And you have to match up. These are the y values. You have to take the second value in each coordinate over the x values, the first value in each coordinate. So I get negative 1 over negative 6. Negative over negative is a positive. If I had done it the other way, if I had, instead of having 4, 2 be x sub 1, y sub 1, I had it be the x sub 2, y sub 2, I would have gotten positive 1 over positive 6, which still would have been positive 1/6. So you're going to get the same answer regardless. Okay, now AD. Now what you should notice about AD is that it's going straight up and down. This is a vertical line. And so we have, for A, we're at negative 2, positive 7. And for D, we're at negative 2, positive 1. I have the same x value. Now that does bring in a little bit of a problem when we subtract. We're going to have negative 2 divided by negative 2. So if I do that, I'm going to have a 0 on the bottom. Now you remember our conversation in class the other day. This is division by 0, and division by 0 blows up the world, so we don't want to do it. So instead, what this is called, this slope, is we call this slope undefined. So the slope for AD is an undefined slope because it is a vertical line. Okay, we want to find the slope of JK, with J being 3, 1 and K being 2, negative 1. Again, it doesn't matter which one I call my x1, y1 and which one I call my x sub 2, y sub 2. I just have to stick with one. So if I start with J, I start with the y value at J, then I also start with the x value at J. If I start with the y value at K, I start with the x value at K. I just have to be consistent. Okay. So I'm going to let 3, 1 be the x sub 1, y sub 1, and 2, negative 1 be the x sub 2, y sub 2. So I'm going to take the negative 1 right here, this negative 1, and I'm going to subtract positive 1. Negative 1 minus 1 is negative 2. And then I'm going to do the same thing with the x value. I'm going to take that positive 2 and I'm going to subtract the negative 3 from it. So I'm going to get a negative 1 there. So I'm going to negative 2 over negative 1, positive 2 as my answer. But remember, if I had switched this up, if I had said that this coordinate was really my x sub 2, y sub 2, and that this coordinate was my x sub 1, y sub 1, then what I would have gotten would have been a positive 2 over a positive 1, and it still would have been positive 2. So again, it just does not matter which one you assign. Alright, so here we're going to graph the lines, and then what we're going to do is use our rules about perpendicular and parallel slopes. Remember, parallel slopes had to be, parallel lines have to have the same slope. Perpendicular slopes have opposite reciprocal slopes. Or another way of putting that is, if you multiply the slopes, you get negative 1, because opposite reciprocals multiply to give negative 1. So we're going to try to determine if this is parallel, perpendicular, or neither. So we'll graph the UV and the XY based on the coordinates that are given here. So that's what they would look like. Now, at first glance, it appears they might be perpendicular, and so that's what we're going to be checking for. So we're going to check the slope of UV, and we're going to check the slope of XY. So for UV, again, it doesn't matter which way I go, but I'm going to take the y values. So I'm going to do negative 1 minus 2, which is what we see here, negative 1 minus 2, over negative 1 minus 0, which is what we see here. Okay? That gives me negative 3 over negative 1, or a positive 3. Now I'm going to do the same thing for x. So I'm going to take 3 minus 1 over negative 3 minus 3. Doesn't matter what markings I'm using here. I'm just trying to show you that it's the same thing for the y's, same thing for the x's. Okay? So I get a positive 2 over a negative 6. That reduces to negative 1/3. Well, since 3 is really 3 over 1, then the 3 over 1 has gotten flipped to 1 over 3, and the positive has become a negative. So that's the opposite, and this is the reciprocal. These are opposite reciprocals. If they're opposite reciprocals, the lines are perpendicular. Another way of looking at that, as it says here on the screen, is if I multiplied 3 times negative 1/3, I'd get negative 1. Another way of knowing that your lines are perpendicular. Okay, these look as if, just at first glance, it's going to be neither. It doesn't appear to be perpendicular and definitely not parallel since they're intersecting, but we do need to confirm it. So once again, we'll find the slopes for GH and the slopes for IJ. Okay, lining up the pieces for G and H. So I'm taking the taking the positive 2 in H, and I'm subtracting the negative 2 in G, and then I'm putting that over the positive 1 in H minus the negative 3 in G. I get 4 over 4, or a positive 1. Do the same thing for IJ. And in IJ's case, we end up getting negative 2 as a slope. Two different slopes, 1 and negative 2, nothing in common. So these are not opposite reciprocals, so this is neither. It's not parallel nor perpendicular. All right, now at first glance, this appears to be parallel, and that's what we'll try to confirm. So we would find the slope of CD and the slope of EF. If these are going to be parallel, they'd have to have the same slope. So again, we're going to apply the values here. Once again, let me just kind of mark the pieces so we're clear on this. For CD, I'm going to take, for the y value, positive 1 minus negative 3. That's going to be what you see on top here. Positive 1 minus negative 3. And then I'm going to, on the bottom, put positive 1 from the x value minus negative 1. And that's what you see down here. So I have 4 over 2 when I simplify that, which is a positive 2. Now I want to do the exact same thing for E and F. So I'm going to take that minus that over that minus that. Doing so gives me another positive 2. Slopes are the same. If the slopes are the same, the lines have to be parallel. I'm going to graph these. Again, determine parallel, perpendicular, or neither for WX and YZ. Here's what we see when we graph WX and YZ. What appears to be a vertical line in WX and a horizontal line in YZ. We're going to confirm the slopes of those. WX looks like I have division by 0. That tells me my slope is undefined. For YZ, my slope is 0. And an undefined slope and a 0 slope do represent those slopes of a horizontal and vertical line, and horizontal and vertical lines are always perpendicular. So these two lines will be perpendicular to each other. Okay, so your quiz to bring to class with you. We want to answer these 3 questions. Find the slope in 1, and then in 2 you're going to have to find the slope of each of the 2 lines and then determine whether or not they're parallel, perpendicular, or neither. Bring that with you to class, and I will see you then. Have a great day.